does it mean to take the limits of a function? Say we consider a function and all of a sudden we are asked to find the limits of that function. What does it mean to find the limits of a function? Let's consider a guy. If we have f of x equal s squared, if we consider f of x equal s squared, obviously we know this is a curve and it opens up. Let's graph it together. Let's say we have okay, so this opens up, voila, you get it, and this opens up and it's from the origin, right? Why? Because if you put 0 here, 0 squared gives 0. Now let's define our limit using this curve. We want to see the idea of limits for me, and mostly for mathematicians generally, is to check or to look, or to let me say check. We want to see the behavior of this function as s is trying to go towards a particular value. The idea of finding the limits of a function is we trying to see, for example, look at this. This is 1, right? Let's say this is 1. We want to see the behavior of this function as s goes to 1. We want to see. Now look at, this is 1. Let's say this is also 1, right? This is 1. Now we want to see the behavior of this function as x gets close and close and close to 1. When I say close and close to 1, I mean we want to look at the neighborhood of 1. What are those numbers very, very close to 1? What is the behavior of this function when s, let's picture it from the right hand side? We could say 1.01, 1.001, we could say okay, let's picture it from 1.0001, 1.001, 1.01, and probably 1.0. Okay, we're trying to see as all of these things from the right hand side as they are moving close and close to 1. What is the behavior of this function? What is exactly happening to this function when x is going to 1? Okay, so now look at it very well. As x is going towards 1 from this right hand side, we see that if we put this here, we see that this is going close and close and close to 1. You see that? Because all of this squared will give you 1 point something. All of this squared will give you 1 point, and 1 squared is exactly 1, right? So we see as the idea of limits is not the value, but the neighborhood around that point. What is the behavior of the function around this neighborhood? What is happening to the function? Now when we take this, you see, now when we take it from this side, we could picture 0.9, 0.99, 0.999, 0.999, and probably we just say 1, from this side. Now 0.99 all squared, it will output 0.81. This should probably give 0.9801, I think. Yeah. So this could be 0.98001. So can you see? So this is also moving very close and close to 1. Can you see? both from the left hand, from the right to the left, the function is, as x is going close to 1, the function is heading to 1. That's the idea of limits. So we could say that taking a function f of s, if x is going to a, this function, the limit of this function is L, which we call the limit. Are we together? Now let's try to consider, let's say we consider another function. Which one should we, let's say we, because the one we considered before is a continuous function. Let's try to consider another function that is not, let's say we have this f of s equal 1 over x. Okay, now look at the behavior. We want to see the behavior of this. Let's quickly graph it. You can use Desmos to check or to graph this. But if you graph this, this is going to look like this. I'm so sorry, my hand is not that straight, but then look at this too. This is going to, you see something from this graph. Something is happening here. If you look at it very well, you see that they're just trying to run away from the origin, right? They're trying to run away, like, I'm not going there. I just want to, try to be, from the negative side of x. This is from the positive side of x. So what we're trying to see here is just that, how do I put it? If we consider 0 from the positive one side, 0, if we consider 0 from this side, that will be, that will be 0.0001, 0.001, 0.001, 0. How do I put it? 0.1 and maybe 0. Okay, 0.1. Okay. Now you see that as x is, this is 0. This is 0 here. If we put 0.0001, as x is becoming extremely small, right? Look at this. Look at this. We have 0, we have 1, we have -1. So if we consider it from this side to the same thing, maybe -0.001, 0001, negative, all of that. But then let's just pick this positive side. We could pick negative, but let's just, if you put x equal this here, you see that this is going to be 1 over 0.0001, and that's 1 over 1, 2, 3, 4, 10 to the -4, 1, 2, 3, 4, 10 to the -4, and that's giving you 10,000, if I'm not mistaken. That's, you see, as x is becoming so small, as x is becoming so small, as x is getting close and close and close to 0, x is getting close and close and close to 0, y is becoming big. You get that? Y is becoming extremely big. Big. So this is the idea of a limit at 0. As x is becoming extremely small, infinitesimals we call them, very, very small number, incredibly small. You see, y is becoming large. But something happened. Something will happen if x, something will happen, or let's say something will happen if x goes close to 0. If x is 0, if x is 0, what happened? This function will be undefined. This function will be what? Undefined. And when it becomes undefined, see, that's why we have the gap here. Not like it's not continuous at when x is 0. But we are checking at the behavior of the function. Can you see? So limit is the idea of you telling you that we are checking the neighborhood around that point, not necessarily the point. Voila. That's what limit means. So now when you see that as x is going to 0, as x hits 0, there is a truncation here. The machine will just get spoiled, right? So now that's limit at 0. Now what if we consider limit at infinity? Limit at infinity. Let's put it this way: as x is becoming big and big and big, as this is the idea of infinity. So as x is becoming extremely big, let's say we say x equal 100. 100, we have 1,000, we have 10,000, we have 100,000, and we have 1 million. A million, right? A million, yes. So as x is getting big and big and big and big, you see that you get to a stage that y is extremely small and y gets close and close to 0. Not necessarily, it's not going to be 0, but it's extremely it's extremely small that we are going to consider it to be 0. That's why you see that if we have, f of s equal 1 over 100, this is 0.01, right? So f of s equal 10,000, this is going to be 0.0000123 4 5. Okay, 1 2 3 4 5. Yes, can you see? So as x is becoming big and big and big, limits as x is going to infinity, the function is approaching, approaching 0. So that's the idea of what limit is. That's the idea of what limits is. And in our next video, we are going to see how we evaluate limits, which we have a little idea of it here, which is the method of what we call direct substitution, which we are going to consider in our next video, and also some setbacks in limits. Thank you for watching. I'll see you in my next video.